I'm Sherry, the Water Resource Planner for the Commission. These are my interns, Vivian and Lydia. You should be seeing them again. They will help you walk through. So anything that you don't catch here, don't worry about it. We'll definitely be there so that we can help you with it. And Sarah, can you introduce yourself?
Hi, I'm Sarah. I'm hosting this training for you over from the School of Marine Science and Technology over in New Bedford. I'm a research assistant with the Coastal Systems Program. I've worked here for 23 years.
Nice. Sherry?
Oh, hey, I'm Sherry Countryman. I'm the president of the Lagoon Pond Association. Also have some other roles and stuff that aren't pertinent today, but there were some other people from the LPA that also want to participate, but were, because of work and stuff, they weren't able to get on this Zoom today, but they will watch the recording, I believe.
Okay, great. Thanks. Becky?
Hi, I'm Becky Rivera. I'm on the board of the Lagoon Pond Association and looking forward to helping out with the testing.
Thank you. And David?
Also with LPA, live on the lagoon. Happy to help out. We have done water quality testing before.
And Robert?
Hi, I'm the Lagoon Pond Association intern, Robert.
And I'm sorry that I can't read the couple in the couple in the corner.
You're muted.
You're on mute.
Corner in another corner.
Yeah.
Oh, we're on mute. Sorry.
There you go.
Yes, we're David Forbes and Jenny Sherwood. We're also members of the Lagoon Pond Association, and we live on the water and we're interested in water quality. So
Great, thanks. And Danielle?
Hi, I'm Danielle Ewert. I'm the Tisbury Shellfish Constable. Been here for like over 13 years working in shellfish and do a lot of water quality. All right.
Great, thanks. Okay, Sarah, take it away.
Okay.
Thank you so much for doing this for us.
Yeah, no worries. This is my first time trying to do a hands-on training via Zoom, so it might be a little bit of a learning process for all of us, but any questions that you have, it sounds like when you go out and sample, you will have Sherry or one of the people that already know a lot of these protocols out with you for the first time. Sherry emailed everyone a data sheet and a protocol packet. I'm not going to be reading through the protocol packet, but it's something that you can refer back to if you have any questions. Basically, what we're going to do is we're basically just going to go through the data sheet that you all have, if you have it in front of you. If not, that's no big deal. And I will sort of do like a mock water quality. So first and foremost, thank you all so much for helping and volunteering. One of the biggest things that we're trying to do is we're trying to get a snapshot of all of these different estuaries. And, multiple stations and data are collected throughout each of these estuaries. So if we only had one team or one group of people that were employed to go out and collect these samples, it wouldn't be a snapshot because it would take 3 to 4 to 5 hours. So having multiple groups and multiple teams to be able to go out and collect this data all on the same day with the same tide is very important. We're trying to get data that is apples to apples. So the protocols that we're using here are protocols that are used throughout southeastern Massachusetts, all over the Cape, all over Nantucket and Martha's Vineyard. A few things. So one of the main things that we're looking for is the worst case scenario. So that is why we pick the sampling times and the dates that we do. We're looking at the worst case that these estuaries have to go through. So during the summer months, that's when we have the most sunlight, the temperatures are the highest, and it's when we see the worst conditions in these estuaries. So we try to sample in June, July, August, September. Those are the months that we're most concerned with because that's when we're going to see the worst habitat quality happening. We also are testing for dissolved oxygen. And dissolved oxygen, if we're sampling out in the middle of the day, a lot of the low dissolved oxygen is related to the amount of algae in the water, which seems sort of odd because algae actually photosynthesizes. So if you were to go out and sample example, at 10, 11, 12 in the afternoon, when the sun is beating down, all of that algae that's out in the water, it's going to be photosynthesizing and it's going to be giving off a lot of oxygen. And it would look like these systems have a bunch of oxygen and that the shellfish and the fish and everything is happy. What we're trying to do is we're trying to see the worst case scenario, like I just said. And that's why we try to sample as early as we can in the morning. When the sun goes down, all of that algae is no longer photosynthesizing. They're no longer adding oxygen into the water column. And any of the algae that has already died and has sunk to the bottom is beginning to degrade. And the bacteria in the water that is eating away at that algae is actually taking oxygen out. So we go out first thing in the morning because the whole night, all those bacteria are eating away at all the dead algae on the bottom of these estuaries and taking oxygen out of the water. So if we go out first thing in the morning, that's when we're going to get the lowest oxygen. And that's when we're going to see what these environments and what these fish and shellfish have to endure and what the worst case scenario is. We also, I know some of the sites that we're sampling are freshwater ponds that don't have a tidal input. But we also always want to make sure if we're in a system that is tidal, that we're sampling on an ebb tide. We don't want to have the fresh water coming from the ocean into the estuary because that's going to dilute the conditions that are in the estuary. So we're trying to get everything that is pulling off of the watersheds and going into the estuaries, again, just to see all the nutrients that are coming from the watershed and not being diluted from the fresh ocean. So those are kind of the main reasons why we pick the samplings that we do. Sherry comes up with a schedule based on the information I just gave you, the tide, the time of day, and she knows where all the samples and that stuff is, so she can explain all of that information to you. It sounds like you all have teams, and when you go out, you're going to be sampling on a boat. So when you go out and you sample on a boat, you're going to drive to your first station. There's specific coordinates, so we're collecting the data from the same locations every time. And when you drop your anchor down, you're going to create a plume of sediment or fluff or algae from the bottom. So once you drop your anchor down, you also don't want to start immediately to collect your samples because you're going to be picking up the sediment and things that aren't actually in the water column. So I'm pretty sure that the way it works is Sherry will have coolers set up with the IDs, the sample date, the system that you're in. She'll hand you a cooler with some ice packs in it, and you'll probably have a clipboard with some blank data sheets on it. So we're just going to run through this information on the data sheet, and we can kind of do a mock sampling. The night before, I'm not sure how your sampling kits work, but usually what I do is I go through my sampling kit and I make sure that all of my equipment is there. I'm not sure how well you can see, but in each sampling kit, you would have a Secchi disc, which we'll talk about a little bit later. You'll have a couple of syringes and a filter housing. You'll have some filters that you'll filter your sample with, a set of forceps, some reagents, and a dissolved oxygen meter. And you should also have pens and pencils and that type of stuff. So the night before, I always want to check that I have everything that I need. If you're out sampling first thing in the morning and you need something, it's going to be difficult to get it. If you check it all over the night before, you can double check. So when you're out there on the tide and at your sampling station where you're supposed to be sampling, you're good to go. You'll also want to make sure that you have ice packs frozen and in your coolers for that morning. So as I said, when you go to your first sample station and you drop down your anchor, you're not going to want to collect samples right away. So if you look at your data sheet, the top part has a bunch of physical observations that I like to start with. This is also a good time, depending on if your group has a dissolved oxygen meter, you want to let it warm up. So I typically, when I get in the boat, I will just turn it on. There's an on-off button, and I have it just somewhere safe where it can warm up for 10 to 15 minutes. So does everyone have a data sheet in front of them, or no? Yes? Okay.
Yeah.
Okay, so the first thing you're going to record is the station ID. There's always a prefix before it, and this is really important because there are multiple embayments that we're sampling, and they all have numbers like 1, 2, 3, 4, 5. So if you're at James Pond, you would say JMS, or if you're in Chilmark, it has a specific ID. So you want to make sure you write that down, and then you would write the number or the whatever the sample ID is. For some of them, it could be up, but you want to record that. You would also record the embayment Again, Chilmark Pond, Lagoon Pond, James Pond, to name a few. You would write the sample date, including the year. When these data sheets come into our lab or back to Sherry's lab, we have just folders and folders of them. So it's important to have the year because we have multiple years of data. And you record the volunteers' names. There are multiple times that I actually will go back and ask a volunteer what they meant by some of the information that they recorded. So it's important to know who's collecting the samples, just to make sure that if there is a question, we can go back, or if we notice that there's something happening incorrectly on the data sheet, we can go and make sure that they, moving forward, do the right protocols. So all that information is really important. The next item on the data sheet is your Beaufort scale. Is everyone familiar with the Beaufort scale?
No.
No.
Okay. It is a measurement of the wind speed. So in all of my kits here, and I'm thinking Sherry probably has them too, we have laminated copies of a Beaufort scale. I'm not sure if you have them with you, so I'm going to see if this, let's see. I'm not sure if you, can you read that at all?
No.
Anyway,
We have it on our clipboards.
okay, it's a sheet and it gives you the wind speed, the wind condition, and then the last column is the force. So it's basically a way that you can measure how windy it is. And it gives you little indications of what it's like. So a Beaufort scale of 0 would be a smooth mirror-like sea. Or a Beaufort scale of 2 would be glassy crests, non-breaking. So you want to record that information as well. The Beaufort scale is important for us because if we get data in and it seems like there's a lot of sediment or a lot of turbidity in the sample, we need to figure out if it has to do with the actual system itself, or maybe it's just the conditions that day. So if it was really windy and there's a high force of wind, it's going to churn up some of the estuary, and so that's why we might have some elevated values. The next thing that you would fill out is whether it's an ebb or flooding tide. As I just mentioned, some of your systems are ponds. If it's a pond, you would just write NA for not applicable. And for all of the other systems, you should be writing an ebb or an E there because we want to be sampling on that ebb or outgoing tide. There have been situations where a boat has broken down or volunteers have overslept and will actually miss the tide. And people will go out and they will still collect samples. It's important to know it's a flood tide. Depending on where you're sampling in the estuary and how far the tide has switched, we might still be able to use some of that data. But most of the data from a flood tide actually just gets thrown out because it might be diluting the values that we're looking for. So it's important to record that information for us. The time of the nearest low tide, that's something that you can grab from Sherry. I'm not sure if on the schedule she lists that out for everyone, but you want to record that information as well. Weather conditions, you have 7 choices: cloudless, partly cloudy, overcast, rain. It can be more than one of those. If it was foggy and partly cloudy or foggy and drizzling, you could write a 5/6. It sort of just gives us the conditions of when you're out there. And then the next one is one of the more important ones for this physical information. It's a 24-hour precipitation. So a lot of stormwater runoff, it can affect our samples. So if it rained really heavy the day before or overnight, we want to know that information because the salinity values might be a little bit lower, or we might have elevated values of some of the nutrients. And we could look back and say, oh, okay, this is more of a rain event sampling because it rained really heavy the night before. So it's something that we want to take into account. We don't want to try and make management decisions based on data without knowing all of this information. Because if we're looking at this data and for one day it looks like the water quality was really different or something like that, if we know that it had rained really heavy, we can take that into account when we're doing our statistics or, compiling the data into management scenarios. The next thing would be the wind direction. You would write, northwest, southwest. Most of the time, the wind commonly is southwest. So all of those pieces of information you can write down. The next thing is your Secchi depth. Is everyone familiar? Do you guys see me anymore? Yeah, okay. I blanked out over here. The next thing that you want to record is your Secchi depth. Is everyone familiar with a Secchi disk? No? Okay.
No.
So Secchi disk is a really easy way to look at the turbidity or the clarity of the water. And this measurement is really important because in a lot of these estuaries, there used to be eelgrass. And if the sunlight isn't able to reach down to the eelgrass, the eelgrass isn't going to be able to grow. So knowing the clarity of the water and how deep the sunlight is able to reach down into the bottom is important to see if things like eelgrass or other plants are able to grow that aren't the algae that's clouding up the water. So to do your Secchi disc reading, everything that we do here is in meters. So some of the Secchi discs that we have here, they're in feet on one side and in meters on the other side. So you want to make sure that you're looking at the meter side of the tape. And there's a white and a black circle on it. To try to make things consistent, you want to make sure you don't have polarized sunglasses on because it allows you to look deeper into the water column. So over the side of the boat, you would just drop your Secchi disc down over the side. In some of your places, there might be some current. So you want to make sure that you're not drifting because you're not going to get a great reading. But you're going to drop it down to the side of the boat until you can no longer see that white and that black. Where the water is touching the meter line, that would be where you record the disappearing level. Then you would raise it up slightly until you can just see the disc again, and that would be your reappearing. And the average of those two numbers is what your Secchi disc number would be, or your Secchi depth would be. And that's a measure of the light and how far the light is being able to get down into the estuary or into these ponds. Some of your spots are going to be shallow enough that the Secchi disc will go all the way to the bottom. You can just write bottom as your number, or you can just write that depth as well. After you take your Secchi depth reading, you're going to drop the meter, the Secchi disc down all the way to the bottom, and you will record the total depth of the station. Again, you want to make sure that you're not taking one like this. You want to make sure that you're as straight up and down as you can. And when you do that, you would record the total depth of the water station at that spot. One thing that's a little bit, this is a side note that I've learned over the years that I've worked here. The way that these meter discs work is a lot of times, if you roll it up using this, it puts a lot of tension on this meter line, and they oftentimes break. So what I typically do is I'll actually raise the Secchi disc back up using it in my hands, and then once I get it back into the boat, I use the reel just so there's not as much tension on the line, and that really helps preserve the Secchi discs. They're back ordered this year, so we're trying to make sure we don't lose any. So now,
May I ask a question?
yes, of course.
So I'm just thinking about the issue of drifting and so on. I'm wondering, is it better to do all of this at slack tide when the water is sitting still? Because otherwise I'm thinking, even if you have an anchor in, you drop this Secchi disc over, it's gonna be at an angle almost immediately from the flow of the water.
It depends where you are. I mean, I've sampled probably 30 different estuaries. There are only a few places that have a current that is strong enough to do it. They're weighted. I don't know if you can see it, but they have 3-pound weights on them. So they do go they will go down unless you're sampling sort of near the mouth of an estuary or somewhere like that. We don't really have those issues. And there are tricks to it. If you know it's going to drift a little bit, you can kind of like throw it out the opposite way, and then by the time it drifts back, you can do it. You'll see once you get out there, and if there is a problem with drift, there are other things that we can do. I don't know, I mean, Sherry would know better. I haven't really sampled too much out in Martha's Vineyard, but in some sites that do have a lot of current, we also have like really long metal poles that have markings on them too. And you can just hold the metal pole and drop it down, and it will have a Secchi disc on the bottom if that becomes an issue for you. But I mean, Sherry, do you think that'll be a problem for anyone?
Not for most of the sites now. We run into that like under the bridge at Senjiktak if we hit it and the tides are changing, and sometimes we just can't do it because we've broken, it's so strong, we've broken the Secchi. So at that point, we just put an NA.
Exactly.
But most of the sites, it's not a problem.
If it becomes a problem, just let me know. We do have some other ways that we can get a Secchi disc and a total reading, so no worries. Yes, David?
Does the Secchi depth, what you observed, change between cloudy and bright sunlight?
It does a little bit. It does change a little bit based on if it's sunny or partly cloudy. And if you have polarized sunglasses on, it also depends if you're in the shade or in the sun as well. So those all do vary a little bit. And that's why all of that information that we just recorded, whether it's partly sunny or all that stuff, it all kind of works together to come out with like a total picture for when you guys are all out there sampling.
Thank you.
Any other questions? Okay. So once you've collected your total depth and you raise your Secchi disc up, you've now stirred up the bottom again. So you don't want to collect your samples right away. So if you look on, oh, there's one more thing. On the bottom, it also has observations. If there's birds, if there's moorings, if there's shellfishing, all of this information is also important, especially shellfishing. It can really stir up the water. And if there are a lot of birds, there's one place that we sample in Orleans where there were so many cormorants across the power lines that it was actually causing, they were one of the main reasons why we were having nutrient problems. So those pieces of information are really important for us. So again, as I just said, we dropped the Secchi disc down and now we've stirred up the water. And now we can fill out some important information lower. So if you look down at this bottom square, there's a surface mid and a bottom. So based on where you're at and the total depth of your site will depend on whether you're collecting a surface sample or a surface and bottom sample or a mid sample. Sherry knows all of that information. Your bottles will be labeled that way. But you can now write, so there's a collection depth. So now that you know your total depth, you can write the collection depths in. So the surface is always 0.15 centimeters below the 0.15 meters below the bottom, above the surface, I mean, sorry about that. So you basically don't want to grab water right off the surface because you could pick up pollen. So you could write that down. If you were taking a mid sample, you would take half of the total depth of your station. And then the bottom depth is 40 centimeters off the bottom. So you can record that information depending on where you're going to be collecting your samples. And then you can move on. So the next thing that you're going to do is you're going to collect your dissolved oxygen samples. So there are a bunch of different meters. So I'm going to go through this part a little bit quickly because when you're out with your sampling team, the protocols might shift a little bit depending on what model of the dissolved oxygen meter that you have. But there are some basic things that I can tell you now about using these instruments. First of all, they're pretty expensive. So we want to be very mindful when we're using them. Especially when we're using the probe. So depending if you have an older one, sometimes the probes actually sit into the top chamber. The newer ones actually just have a sheath that go over the actual probe. These probes are calibrated every season before they go out. There's a membrane on them, and inside either the pocket here or inside the sheath, there's a sponge in there that has some dissolved, some DI water in it, just some fresh water to keep the probe moist. You don't ever want to let it dry out. When you go out, like I said, you want to turn it on. You want to let it warm up for a little bit. And when you arrive at your first station, there are different ways that you calibrate the meter while you're out there. The process is really easy. It's either a button that you hit calibrate. If it's one of the older meters, there's just a few little things that you have to do. But Sherry can walk you through that when you are out there. So to collect your dissolved oxygen readings, the lines have all been marked at 0.5 meter intervals. So we'll get into that. There's a spot in the middle of your data sheet that says an initial reading. For that, we're basically just testing to make sure the dissolved oxygen meters are working properly before we start taking measurements. And this is just a reading of what it's like in the air. So we're all breathing oxygen right now. We know we should have a good supply of oxygen. So once you have your meter on, you take it out of the chamber, spin it around a little bit, and you're just going to let it, depending on, again, for some of them, you put it back in the chamber to take this initial reading. So that's going to be dependent on where you're at. But you'll record the dissolved oxygen in milligrams per liter, which is displayed on the screen. You'll write the percent CO, and you'll write what the temperature is. And based on that information, we'll know whether or not your meter is working properly. If you're getting a low milligram per liter oxygen using your meter, and we get all of this data back to the lab, we're going to know that we probably shouldn't use it because it's saying that the initial readings in the air are really low. So then we just throw out all of that data. So it's really important. And that piece of information you collect when you go to each site. In between, keep your meter on because you calibrated it at the beginning. So then when you write, you now have your collection depth already written down, and you will write down your collection time. And then you would drop your meter down to whatever depth you're collecting. So if it's right at the surface, you would go a little bit below the surface. For some of the older meters, the way that they work is they actually take oxygen out of the water. So you kind of have to jiggle the line a little bit to keep it from not continuing to go down just a little bit. So you would record once it levels off. It will fluctuate a little bit, but you will record the oxygen reading, the temperature reading, and then some of the probes have conductivity and salinity as well on them. So you would record all of that information and pH. Sherry, all the meters have all of that information?
They do.
Okay, perfect. So it sounds like you guys all have the really nice new meters, the Pro Solo thing.
We don't have
So
salinity.
all of that information is going to be right on your screen. So you record all of that information. One thing that you need to take into account is if your dissolved oxygen reading is less than 5 milligrams per liter. 5 milligrams per liter is a management number where if it's below 5 milligrams per liter, it is considered the habitat is impaired and shellfish and fish can have problems. We don't want to base those management scenarios or plans based on just a meter. So we actually will collect an additional sample that we analyze in the lab to make sure that the oxygen really is that low. That way we know that when we're going forward and we're looking at the health of these systems, that we are looking at it in a way not just based on an electronic piece of equipment that might not be as accurate as coming into the lab and doing a Winkler titration. And again, we'll walk through this, and then when you're out on your boats, we can talk about that. So now that you have collected all of that information, you can collect your water samples. And I know this sounds like a lot for the people that haven't done this before, but once you get out and you're actually doing it, it takes about 15, 20 minutes per each sample site. And if you're with someone that's done it before, it's really quick. And then once you've done it once, you kind of get in a routine, especially if you're with the same group. One person will be doing the one thing and someone will be the recorder, and it all kind of just, you'll get the flow of it. So most of your groups are going to have what is known as a Niskin sampler. This is how you'll actually be collecting your samples. It works, so it has a line, and on the line, it has markings every half a meter, and it has a messenger or a weight on it. And I know it's going to be hard for me to show from the Zoom, but basically what it does is you open it, and the ends hook together, and there's a spring-loaded device on it. And so you'll drop it down, and when you get to your proper depth, again, straight up and down like I told you about the SECI, when you let go of the messenger, it clicks on this, and then the ends close, and you bring it up to the water surface, and you have now collected the sample from the certain depth. So a couple things I can't really show you from dry land,
Do
but
that on this.
a couple things you want to make sure before you start. There are spigots on both ends. You want to make sure that they're both in the closed position. You want to make sure the line isn't caught up on anything. And then there's just these two little loops on the end, and they just attach to a little pin on it. And once it's in the open position and you're good to go, you just drop it down, and then you bring it to the surface, and someone will hold it, and you'll stick the hose into your sample bottles, and you'll fill them. So for each of your sample sites, you'll have a dark bottle. This we use for chlorophyll A, which is a way that we can measure the amount of algae that's in the water, small particles or algae like phytoplankton type chlorophyll. And then we have this other 1 liter bottle. This collects particulate of carbon and nitrogen. And then you'll have a 60 cc for every site that is a nutrient sample. So this is all the dissolved nutrients, ammonium, orthophosphate, nitrate, nitrite. We run 5 or 6 different assays out of this little bottle. And then depending if you're at a freshwater pond, you might have a second 60 that you have to fill up for total phosphorus. So the 2 1 liter bottles, it's just water straight from the Niskin. These bottles have been acid washed in our lab. You just put the tube in. You want to rinse the bottle a little bit, just to make sure there's no contaminants in it, which they're not because we've acid washed them and washed them out 3 times with water here, but we still like to do that. And if you're one of the people sampling at a pond, same thing. You'll just put unfiltered water. You'll just put it in. shake the bottle up, and it's unfiltered water for the TP. I'm not sure, there are two ways that you can do your nutrients. If it's a nice, beautiful day out and you want to hang out on the boat, I oftentimes suggest that you do the filtering part out while you're out at the station. If not, I think a lot of groups, what they do is they'll make sure they have their 1 liters filled, and then you can do the filtering part back on shore. One thing you want to keep in mind is that these samples need to get back to us. So the sooner and quicker that you can filter your nutrient sample, number one, it's better for the actual sample itself. And number two, it'll get the samples into the cooler, into the ferry in time to make sure we have them. Sherry, how do you usually do it? Do you out?
We usually sample and then bring it back to our office and filter here.
Okay, that's so to filter.
We want to filter really quickly, as quickly as possible after we take the sample though, correct?
Yes, but I mean, if it's like a half hour after, that's totally fine.
Okay.
So to filter, you have, this is going to be kind of hard to show too, but in each kit, there's a filter housing. So there's this like circle part, and then there's a base, and then there's the top, and it's just a key fit. So it all key fits together. Maybe before you all go out and sample for the first time, you might want to just look at what one of these filter housings look like, and you might want to practice. And then in each kit, you have these filters. They are 0.22 microns, so it takes out any of the particulate and it takes out any bacteria. So we're just getting dissolved nutrients. So in between, when you open these packets, there are blue spacers. You don't really want to touch the filters. It's not going to be the end of the world if you touch them a little bit, but you also don't want your hands on them. The oils can create issues. But the spacers are there in case you are out in the field or you do need to touch a little bit. So you just want to use your filter forceps, and you would put your filter onto your housing and put it perfectly on. And then again, it just key fits into place. And then you screw it on. And that is how you put a filter together. So we're trying to filter all of the particulates out of these samples. But the way it works is we're going to be filling up these syringes, and it's just a pressure fit. So you need to be careful that you're always putting the syringe on the filter the same way.
What is that?
A lot of the groups that I work with, I tell them to just put arrows. So this one has an arrow right on it. You just put the arrow down, so you're always filtering the same way. If you were to filter a little bit this way and then filter this way, all that particulate matter is going to go in your sample. And oftentimes we do see that in the lab, and we have to go find a sample and refilter it. So once you have your filter housing put together, you would take 2 of your syringes. You would shake your sample. You just rinse these out a little bit. And then you would fill them both up to the top. And then you would put the plunger back in. And when you do, you can actually, I don't think you'll be able to hear it, but it snaps into place. Once you do that, you get all the air out. And now you have 2 syringes filled with your sample that you're going to filter into your little 60 that's labeled nutrient. The first syringe we use for 2 reasons. We want to make sure that your filter is sitting on the device properly. So again, it's just a pressure fit. It just fits right on. And there's markings on the side that are from 0 to 50 cc's. So for the first like 10 cc's, you just want to push the water through, and it should be coming out of the filter with no water bubbling up around the edges. If there's water bubbling up around the edges, it's showing you that your filter is not put on properly, and you have to stop for a second, reset the filter, and make sure that the filter is actually on properly and filtering correctly. So once you have that set, you use another 10 cc's to just rinse your little bottle out. So you put some water in your little 60 that's labeled nutrients, and you dump that over the side. Then you would use the rest of your syringe and the other syringe that you filled to fill this nutrient all the way up to the shoulder. Like I said, we run 5 or 6 different assays out of this, and then it goes through a QA/QC process here. If we don't have full bottles, we run out of sample and we're not able to run all of the important assays that we need to. So you will fill both of your, using both syringes, you'll fill your nutrient all the way up to the top, and you'll cap it, and you'll put that back in your cooler as well. Your filters, you don't have to switch filters every single time. If it's easy to filter. The filters can get really hard. If you're in a spot where there's a lot of particulate matter in, it's going to become really hard to filter through. And that's something you also want to be careful of. A lot of times the filter housings, which are also really expensive, if you're pushing down really hard like this, the syringes can bend and actually break off inside the filter housings. So I usually try to tell people to hold a syringe with one hand and push with the other hand into the bottle instead of like using the bottle as a way to push down. Is that, it's hard to explain via Zoom, but is that clear how to do it?
Mhm.
So that's how you would collect your nutrient sample. And then once you make sure that you have all of your bottles filled, you're done for that one site. The only thing that you need to be careful about is if you have that dissolved oxygen level less than 5, there's one additional bottle or Winkler that you have to collect. These bottles usually aren't labeled, and I think they're just in your kits. Sherry, you can correct me if I'm wrong.
They are. There's a pen, there's always a marker in there.
Yep, so that's the thing. These bottles, like I just said, they're not labeled because we don't know where or what stations are going to be less than 5 milligrams per liter. So you need to make sure you write it on this. So when we get the sample back at the lab, we know where it's coming from and don't have to play CSI. So for your Winkler bottle, you have these overflow cups in your kit. You would put your Winkler open into it. You would have your Niskin, and you would have, I actually filled a bottle so I could do this. So we're gonna pretend this water is in a Niskin, but it has a tube. You want to take the tube, you want to pinch it off at the end, and you want to stick the tube all the way into the bottom of the Winkler bottle, and you want to let the water drain out until it goes over the top and fills up over. We're basically pushing any dissolved oxygen out of the sample. So right now, you can't really see very well, but the water is going into this Winkler bottle, and it's now filling up this overflow cup. When the overflow cup reaches the top, and it's over the mouth of the Winkler bottle, with the water still running, you want to pull it out. And you will cap it. Inside your kits, you have reagent packets 1, 2, and 3. It is important that you add the reagents 1 and 2 as quickly as you can. We're trying to get a snapshot of the dissolved oxygen right at that very moment. So it doesn't matter which reagent you add first or second, but you want to add reagents 1 and 2 as quickly as you possibly can. They're little pillow packets. They're kind of hard to open using even scissors. But one of them, it kills anything that's living in there. So if there is phytoplankton or copepods, whatever's in there, they're changing the oxygen levels. So we want to stop that from happening. And the second packet takes all of the dissolved oxygen and it turns it into a precipitate. So right now I'm just adding reagent 1 and 2 into my Winkler bottle. And I don't want to add in any air, so I just drop the top down really quickly. And then you want to shake this. And when you shake it, it's going to create like an opaque, see how it's like, you can't see through it? That is any of the oxygen is turning into a precipitate right now. So, and to shake it, you want to make sure that you're not just shaking it up and down like this. You actually want to invert it to get all of the reagents mixing around a little bit. The reagents are designed to have a little bit of extra in them because the company realizes that you're going to be out doing this in the field. So you might be on a boat, so some of it might not go into the sample. So it's okay if all of it doesn't dissolve, but you do want to shake it for around 20 to 30 seconds like this. And now this sample has reagent 1 and 2 in it, and you can send it back to Sherry and back to our lab like this. Or if you wanted to be helpful or have any free time, you can add reagent packet 3, but you have to wait for this precipitate to settle out, and I can show you that in a second. And then once you have all of that, you would pull your anchor and you would go to your next station. And that's basically how you do the sampling.